So today we are going to, it is 1/27, so January 27th, we're going to work on adding rational expressions. But knowing the difficulty level of this, we are going to start at the most absolute basic, and we are going to remember how to add simple fractions with uncommon denominators. All right. So let's start with the most basic. Many years ago, you learned how to add 1/2 plus 1/3. You needed a common denominator. You also learned how to add 2/3 plus 5/3. That had a common denominator. We're going to start with this red one. We're going to take a quick peek at it. Remember that when you are adding fractions, the denominator will stay the same and the numerator will add together. So that rule is you can add the numerators 2 plus 5 and write it over 3, which would be 7/3. You need to know all parts of this rule because when we start adding rational expressions together, sometimes when you add them together, then they can factor back out and do certain extra things. So you need to know how this middle step is actually going to work. Up above, we have 1/3 and 2/3, or 1/2 and 1/3. To add those together, we have to find a common denominator. A common denominator is the exact same concept as a least common multiple. What being the least common multiple of 2 and 3 is the first number they both go into? That answer is what, Kylie? 6. So they both go into 6. So I need to make 2 into a 6, and I need to make 3 into a 6. To make that happen, I would multiply the first one, or the first fraction, by 3 over 3, and the second fraction by 2 divided by 2. That will yield 3 divided by 6 plus 2 divided by 6. Now I can use my rules of fractions. Being that I have a common denominator, I now have 5 over 6. Or 5/6. And that would be my solution. So you have to have a common denominator. To find the common denominator, you use the least common multiple of the two numbers. Let's take that idea and let's expand upon it, okay? So we're going to put it up here in the corner for a minute. Let's start with the basics. These are common denominators, all right? Let's say I have x plus 4 divided by 2x plus 6 plus x plus 2 divided by 2x plus 6. As it stands right there, notice that x plus 4 over 2x plus 6, that does not reduce. Neither will x plus 2 divided by 2x plus 6 reduce. So I have no reducing capabilities here at all. Even though we can't reduce, being that these are common denominators, we can still add them together. So we're going to go to the most basic of addition. We are not going to just go straight into adding, okay? We're going to write down what is being added. We are going to add x plus 4, which is a binomial, with x plus 2, which is also a binomial, and we are going to put it over the fraction bar of 2x plus 6 in the denominator. Right now we're taking a short hiatus from finding points of discontinuity. Hiatus meaning like a small break, because I want you to concern yourselves with getting the proper solutions right now over finding every point of discontinuity at this very moment. We will add that back in, so be aware it's not gone forever, it's just not here today, okay? Then you can add those together, getting 2x plus 6 divided by 2x plus 6, which equals 1. So our solution from that original problem is 1. Yep, you can have 1 as an answer. You can have a simple binomial as an answer. You could have 3x as an answer. If it reduces away, it's gone. It's very simple, it's quick, it's proficient, all right? So let me give you a few of these to try. Take a moment to attempt both of these problems. So these are the two answers I was given. One of these is correct and one of them is not correct. The first answer is in fact correct. You add straight across, you get 2x squared divided by x plus 2. The second answer is not correct because if you were to factor this, I'm going to use blue to show where we could go, you would have 4 multiplied by x plus 2 divided by x plus 4 times x minus 4. The reason the first answer was not correct and this answer is correct is I now have proven beyond a shadow of a doubt that this cannot be factored further. Is that clear? You must prove to me that this cannot be factored further. You must prove to all concerned people and yourself that you cannot factor something further or reduce anything away. So if it's not in a final factored denominator, you cannot say that you have finished the problem. I want you to leave your denominators factored. Is that clear? All right. Looking at both of these, they both seem to have an x on the exterior of the binomial. They both have a 3x plus 2 binomial. But one of these numbers can enter into the other number, meaning it could be a factor, so the other number would be a multiple. If I were to look at this and I would say, okay, what is the least common multiple? Once they're factored, it's really easy. On the left, I have a 2, and an x, and a 3x plus 2. To get to what the right equals, the only thing that I would need to do is multiply that 2 by a 3. So I just added in another 3. Once you are in completely factored form, you can find these least common multiples very quickly. So we're going to look at a couple examples that deal with fractions, because in that form, a lot of people have trouble seeing them as what we're talking about. So let's say I have 1 over 4x plus 1 plus 2 over x. To get the least common multiple, I'm starting off with kind of a simpler one. Is everything factored? Yep. There's nothing you can factor from here. So think of it kind of like sharing. You watch little kids, they don't share well, right? But let's assume for once that little kids do share well. So this is one little kid who has an x, and this is one little kid who has a 4x plus 1. And they are such good sharers that their goal is that everyone would have the same stuff. All right? So this little kid over here on the right says, hey, I would like you to have an x. And on the left, it tells the kid on the right that I would like you to have a 4x plus 1 to match. Before, they were incompatible fractions or incompatible rational expressions, because when your denominator is not the same, there is nothing you can do to add or subtract the two expressions. However, now that the denominators are the same, I can add them together. So rewriting that, I would have x plus 2 times 4x plus 1 divided by 4x plus 1 multiplied by x. Putting that together, you would end up with this right here. I'm doing a little side note. That's 8x plus 2. So that would give you 9x plus 2 divided by x times 4x plus 1. And I would state that is my solution. So my least common multiple was x times 4x plus 1. I need each denominator to have each of the same factors. Once I've done that, to make the denominator have the same factor, I have to multiply the numerator by whatever I multiplied the denominator by, and then combine all like terms as much as possible. So as I already stated, your first goal is going to be to factor your denominator. I don't care if you factor the numerator. In fact, I wouldn't really recommend factoring the numerator. Usually I would factor the denominator. Step 2 is actually reduce again. And the reason it's reduce is every once in a while you're going to get something that reduces to make it nice and simple. Or simpler. Okay? Step 3 will be get the common denominator, and to get the common denominator you're going to multiply both expressions if necessary. You won't always have to multiply both expressions. Step 4 will be simplify and reduce again if possible. I'm going to change one slight part about this problem here. I'm going to change that 3 right over here. That is not changing. I'm going to change that 3 to a 2. So that 3 is a 2. Okay? So let's start with step 1, which is factoring the denominator. If I factor my denominator, the left expression is still x times x plus 2, plus the right expression of x divided by. Kayla, what is x squared plus 2x factor to?
X plus x plus 2. I mean x times x plus 2.
X times x plus 2 is good. So I check real quick, is anything going to reduce here? The x is going to reduce. I'm going to be left with a 1 in my numerator. Do I now have a common denominator? That's why you want to check if you can factor and reduce first, because occasionally you'll end up with a common denominator. That would leave me with x plus 1 divided by x plus 2. Now there's a lot of people out there who right here would think, oh, now reduce the x's and reduce the 2 and the 1, so you're going to have 1 plus a half and get 1 and a half. You can't reduce anything here. This is your final solution. You are done. Do not reduce from this point on. The x's, yes, they both have an x. However, because all parts of both binomials do not have an x, you cannot reduce away an x. And you can't just write it as x over x plus 1 over 2. That's not allowed. That's against the rules of math. So this would be your answer. Let's look at another example. Let's say I've got x squared divided by x squared plus 3. Minus 1/3 x squared divided by x. On the right-hand side, could I reduce this? Sure, I could. But this time it's not going to benefit me because I wouldn't be able to combine my terms. I wouldn't be able to combine either of the rational expressions if I reduce it. So everything's already factored as much as it possibly could be. On the left-hand side, I have an x squared plus 3. On the right-hand side, I have an x. They both need to have both parts, so that would be my common denominator, x squared plus 3 multiplied by x. So on the left expression, it needs an x, an extra one. On the right expression, it needs an x squared plus 3. Now that I have multiplied both steps, I'm going to multiply it out and write it over x squared plus 3x. So the question was asked, could we have canceled that x? Yeah, we could have canceled that x and just had x squared plus 3 in the denominator. We will end up factoring out an x in the end, so either method would have worked. But we're going to continue with this one just so that we don't restart and get it super confused. So that would be x to the third minus 1/3 x to the fourth minus x squared that 1/3 and 3 cancel out and just make a 1, divided by x multiplied by x squared plus 3. Notice that I left the denominator factored. And that minus 1/3 is supposed to be x to the 4th right there. Thank you. It was noticed that, well, we're going to be able to cancel out that x, so that 3, that 4, and that 2 are going to now cancel to x squared minus 1/3 x cubed minus x, all divided by x squared plus 3. I could continue to factor that numerator, but knowing what I know and knowing what you know, hopefully you would notice this is not going to factor at this point to anything beneficial. So you could consider that a perfectly acceptable solution because my denominator has been left in a factored state.